For solving radical equations. The first objective in this topic is to state the domain of a radical equation. There is something unique with solving these types of equations because of the radical that exists in it. And I'm going to scroll down to the example I'm going to do over here. If you notice, the variable is underneath the radical. And so there is something that variable has to be bigger than, because if you remember from Module 2, taking the square root or taking a radical of anything, there's a certain type of number you can't do that with. And if you remember, like for example, so that's the first question I asked, what type of number can you not take the square root of or just take the root of? Let's say, for example, square root of 9, that's fine, it is 3. And then the square root of another example, square root of 2, is fine. It's just an irrational number of 1.4142, something like that. The square root of 0 is fine because it comes out to 0. But if you remember, let's say I take the square root of negative 9. What happens there? Technically, you enter into the realm of imaginary numbers, and you have to represent that with I. But in the purpose of solving equations, that can't exist because you can't technically take the square root of a negative number. And so everything underneath the radical has to be greater or equal to something that's not negative. And the lowest number that's not negative is 0. So everything underneath the radical has to be bigger than 0. So x can't be a number that would make the radical 0. It can't. It doesn't work. Similar to rational equations when it exists in the denominator. So I wrote this out in blue. The process of finding the domain for these equations is to set what's underneath the radical greater or equal to 0 and solve for the variable. So that's what I'm going to do for two different problems, all right? The first one, again, all I care about for the domain, this isn't technically solving the equation, it's just stating the domain of what x can't be, all right? All I care about is what exists underneath the radical. It doesn't matter what side of the equation the radical is or how many radicals exist, like in number 7 there's 2 of them. I just set what's underneath the radical greater or equal to 0. All right? So underneath this radical is 24 minus 2x. And it has to be greater than or equal to 0. And then it's just a simple process of solving for the variable. So a lot of times this is an Algebra 1 skill, just solving a linear equation. In order to do this one, the first thing I notice is that this 24 is on the left side of the equation with the x, and it's furthest away, so I'm going to kick that out first. It's a positive 24, so I have to subtract it. I do that to both sides. Makes it go away over here. I'm left with negative 2x, which is greater than or equal to negative 24. 0 minus 24 is negative 24. Next step, this negative 2 and that x are multiplying on each other, so I have to divide that negative 2x. And if you remember, when working with equalities, when working with inequalities, if you ever divide by a negative number, which I'm doing right here, I'm dividing by negative 2 right here, then you have to switch the sign, or switch the direction of the sign, all right? And so my final answer then, instead of x is greater than or equal to, x is going to be less than or equal to the direction of the sign switched. Negative 24 divided by negative 2 is positive 12. So the domain, x has to be less than or equal to negative 2. All right? So this is my domain. Please label that whenever you're doing this as well. Let's check this work just so I can explain to you why this has to happen. If I plug 12 back in for my x underneath the radical, I have 24 minus 2 times 12. Which goes to 24 minus 2 times 12 is 24, which then goes to square root of 0, which equals 0. Good. Now, x has to be less than or equal, because again, if it equals 12, fine. The square root of 0 is 0. That's fine. That's happy. But it has to be less than or equal to 12. Because let's say I make it 1 bigger than 12. 24 minus 2 times 13. Breaks down to 24 minus 2 times 13 is 26. which equals the square root of -2, which can't happen. Alright? So if x was bigger than 12, even 12.1, technically it would be a -0.2 then. Anything bigger than 12 would break the domain. This is why x has to be less than or equal to 12 in this situation. Because if I put something bigger than 12 into x, you would be taking the square root of a negative, which doesn't work. Alright? One more example, then I'm going to have you try it on your own. So in this case, the reason I want to show you this is because there's two radicals. Same process. I'm just going to do two different domain discoveries. Alright? I set what's underneath the first radical, greater or equal to 0. So -8 minus 3x is greater than or equal to 0. I solve for x. So in this case, this -8 has to be added to both sides to cancel it out on the left side to get it away from my x. So I have -3x is greater than or equal to +8. Divide by -3, divide by -3, x, I divided by a negative, so now x is less than or equal to -8/3. So my domain, x has to be less than or equal to -8/3 for that side. And over here, I set it equal to -4 minus x is greater than or equal to 0. I have to add 4 to both sides. Add 4. That cancels it out over here. I have -x is less than or equal to, I'm greater than or equal to 4 now. And then I divide by, technically this is being multiplied by a -1 whenever there's a negative out front of a variable. Divide by -1, divide by -1. That cancels it out. I have to switch the sign though because I divided by a negative. X is less than or equal to -4. Alright? So I will, again, prove this for both sides. I'll do the -4 first. If I plug -4 in for right here, I have -4 minus a -4 equals the square root of minus a negative becomes plus, -4 plus 4 is 0. So this equals 0. That's fine. What if I did something, because again, x has to be less than or equal to that. So what if I did something that's bigger than -4? In this case, it's kind of tricky, but -4, bigger than that would be a smaller negative number. So I have -4, let's say minus a -3. -3 is bigger than -4. In this case, then you do plus plus. This would give me a -1, which can't happen. -4 plus a plus 3 now is a -1. Breaks the domain. So the domain has to be less than or equal to -4. Go ahead now and try your example on your own. State the domain of what x has to be greater than or less than or equal to. Alright, so please pause the video and try it and then check your work with mine. So at this point you should have paused the video. I'm going to show you step by step how I would. Again, really the only step is to set what's underneath the radical greater than or equal to 0. Then solve for x. This one's pretty simple. I add 3, so x is greater than or equal to 3. And I'm done. Let's check our work though. Hopefully you got x is greater than or equal to 3. If you didn't, please raise your hand and I'll come check your work. Well, let's check our work with this statement about the domain. If I put 3 back into the domain, I get the square root of 3 minus 3. Which is the square root of 0, which is fine. I get 0, that's fine. Now it has to be greater than or equal to 3. So let's try something less than, just to make sure we did this right. Let's try the square root of less than 3 is 2. If x was 2, which is not greater than or equal to 3, it will indeed break our domain because 2 minus 3 is a -1 and I can't take the square root of a negative. So I know that we solved that correctly. All of my x's for that domain have to be greater than or equal to 3. Go ahead now and work through the practice problems. Your goal is 6 out of 6. Sometimes if there's problems that have 2 radicals, then you have to do the process twice to state the domain for each radical. Again, notice in number 5 that negative 2 is being multiplied, but again, I don't care about that. I just care about what's underneath the radical, setting it greater or equal to 0.